Okay, hello, good afternoon. I am Anto Budiarjo and welcome to Monday Live. This is something that we do every Monday afternoon, 3 p.m. Eastern, to figure out the advances and other related stuff to smart buildings and how to make buildings smarter. Just in case you're wondering who we are, a list of our profiles are on mondaylive.org. Also just to point out, the views expressed here are personal, not of any company or organization. Please do post questions, comments, and other chit chat on the Zoom chat. We really appreciate it when we have a lot of interaction, so looking forward to that. And also this slide deck is also available on mondaylive.org in case you want any of the links from it. Throughout this month of April, we are talking about cloud, or the computing cloud, and buildings and how they intersect. And so our agenda for today, our normal chit chat for a bit, and then talking about really the impact of what's known as cloud native, which is a paradigm that is a computing paradigm that is used in the cloud. So we'll discuss all of that once we get going. But before that, I'm going to hand it over to Ken, see what's going on in the automated buildings space. Len.
Thank you very much. Okay, I just got the article for Contractor, and the title is Environmation is the Dawn of a New Era. And I talk about all the eras we've gone through: pneumatics, internet, IFT, cloud, and basically I'm trying to spin the concept that we name this new era that we're about to enter into environmation, a combination of the environment and the automation of the environment. That inspiration came from the ControlCon theme this year, is the dawn of a new era. So I was putting together a video for that, and I got thinking about it, and this kind of all came about. So you can see what we're thinking there. Something that came across my desk from the consulting company, the kids consulting company, they're basically posted this, that they've got free energy and carbon reporting supported for 100 multi-families in Vancouver. And I think this is a trend, I think in the decarbonization, Western Canada and probably Western US in a lot of ways is kind of leading the charge. But this is an interesting post, I thought, anyway, because I think you'll find, I think New York is close to doing something like this as well. So we have hotspots of decarbonization. I think decarbonization is probably a great killer app for the automated building industry and the analytics industry. So I think that where in the past we were counting and reporting on energy, we're now going to be reporting on how much carbon we're saved. This fits into the ESG stuff we've been talking about before as well. Sort of feeding off of that, we've kind of found that one of our greatest resources is our contributing editors, and we've tried to streamline that a bit. We've got a new page out that you can kind of click on the icon for each of our contributing editors and catch up on what they've written over the years. And some of that goes back quite a few years. Mr. Peacock would be one of those people, and actually Anto as well, because it goes back to the days of BuildCon and Connectivity Week. So yes, a lot of information from one click, kind of quickly catch up on the history on an individual basis. Another one that caught my attention was a post that was done by Brian Turner, which we all know, the evolution of the building systems, MSI. It's a really good article that he starts, and he goes about both the pros and the cons and some of the inner workings of all of that. It's a really good article. a lot of our contributing editors have jumped in and added dialogue to that. So that's certainly a post I think you would like to take a look at. That also leaves me with, we're still in the midst of this reinvention of automated buildings, and I'm still trying to figure out how best to capture all of the dialogues that go on LinkedIn. A couple of years ago, the industry wasn't widely using LinkedIn, but now they are. And I'm having trouble getting my contributing editors to post on my site, but they seem quite verbal on LinkedIn. So I'm not sure whether the best route for me is to just curate their thoughts and provide links to them, because typically the discussions are good, but in addition to what they've proposed is that the industry now breaks out in very useful dialogue, and I'm still trying to figure out the best way to bring that into the context, a library of automated buildings. So if anybody has any ideas, please share them with me. Back to you, Anto.
Okay, thank you, Ken. So I had one news. Obviously, this is a theme that we've been watching, but this guy who's obviously somebody in real estate, the Texan guy who made a killing in 2008, basically said, telling us all to tear down the commercial real estate, or a lot of the commercial real estate that's surplus to our requirement. So that's pretty sort of pushy or out there. But the other thing I thought was sort of interesting is that, you know, obviously we're trying to sort of figure out, or a lot of REITs are trying to figure out the valuation of their assets. And this comment about the Bloomberg index for REIT is down 50%, right? So the comment here is that he's not shorting it because it's already shorted by, or the price has already taken that into account. So 50% seems to be the starting point of where the new valuation would be. Is that the way I should interpret this? That's pretty something, right?
Yeah, I did read somewhere, Anto, that similar online to this, whether it's the same guy or not, was that any buildings that are up that prior to 1980 just are, you know, there won't be possible to actually retrofit or refurb or do anything with them, because they're, you know, they're not fit for future purpose, if you like, and should be considered, as it says here, tearing it down, because they, you know, they couldn't even be converted into apartments or anything because they're just wrong.
I thought maybe this guy was a real estate developer posing as an investor. Tear them all down so I can rebuild them all right. Yeah.
Yeah, the article goes into a little bit of discussion about what to do with the space. But quite ballsy. And it's kind of interesting. Obviously, one of the conferences that's coming up in a couple of months is Realcomm. It will be interesting to see what the mood is there about all of this, because a lot of REITs obviously go there. Rick, some updates from you? Muted.
There we go. Sorry about that. Yeah, as depressing as the commercial real estate market seems, you know, perhaps there's some things that technology can do to reinvigorate what buildings are left or still needed. And part of what I've got here on the collaborations is the fourth bullet down there of the Building Energy Exchange is something that I think last week I talked about, that Monica and I are attending. It's a Kansas City, St. Louis, New York City, Minneapolis, Detroit. There's a bunch of cities that are part of this network. And it's interesting to see what these different communities are thinking relative to the reinventing of their cities and their downtowns, and how to make their cities competitive. And it's far less depressing as from what the sounds like the commercial real estate folks are. And I don't know if that's just because a bunch of us are still just really optimistic about the future of buildings, or if it is maybe because we've kind of all seen this before. Well, actually, 100 years ago, some cities went through a tremendous downturn in the usefulness of the building stock that they had, and that had to be reinvented. Seems like the same thing's happening again. Anyway, that's a little comment. We've got a couple of collaborations that are moving forward that are pretty exciting, where the coalition is helping to give content to organizations like BIG. And we're going to participate with them in a meeting coming up in June. And then we're working on how to bring some content to some of these other organizations, including the Haystack Connect, Realcomm, as Anto said. And then what I was just talking about with this building energy exchange. The other points that are up there on the slide are the ones we talked about last week, and we're still excited about what's happening with the Young Professionals Group that's up and running now, and they'll be talking about that. And we're continuing to develop out the scripts for some of these video podcasts that we've talked about. So that's what's going on with us.
Great, thank you. This is just here if anybody wants any of these links for various interesting links and trade shows. And before we move on, any other thoughts or perspective anybody wants to bring up?
I'm hoping that Rick is sharing some of that stuff with automated buildings. In fact, I think I'm waiting hopefully for some posts.
Cool. All right, so let's go to the clouds. This is the third week talking about clouds. If you recall, the first week we were talking about sort of the progression of computing from single computer to the typical controls network that we have, and into the multi-cloud computing paradigm depicted here on the right. So we spent the first Monday talking about that. Last week, on the second Monday, we focused in on the on-prem part of it, because the multi-cloud includes public clouds, meaning AWS and Azure's and Google, etc., and private cloud, or obviously in our case, typically the building owner or the enterprise. And the on-prem is something that the coalition is working on with a project called the IBB that we talked about last week. So really the conversation this week is really about cloud native, and cloud native is really how this works, how the cloud infrastructure actually works from an application perspective. And I just put up one definition that I found on the web, and I'm going to bring in Toby Considine, who can actually speak much more eloquently about cloud native than this. But the concept is really about running applications to take advantage of the cloud being a distributed computing environment that we talked about the last couple of weeks. And so cloud native apps are designed specifically to exploit those that don't exist in any other paradigm, don't exist in a single computer or even in a local network computing environment. So I'm going to bring in Toby, and we can dig in a lot more about cloud native. Toby is joining us. There is Toby, and I'm going to bring this down, the slides down. So hello, Toby. If you can unmute, put the camera on.
Turning off all the automatic muting and decamerization that being a attendee goes.
Okay.
So good morning, good afternoon, good evening, as appropriate. Unfortunately, talking about cloud computing requires a little bit of vocabulary, just because we keep on changing what the words mean. And if you think that means what they meant last year, then you're missing the boat again. I've got a couple slides, or I could just talk through them. Your choice. Do I get to?
Yeah, bring them up. Bring them up.
Okay.
Go ahead.
How do I do this? Okay. Turns out I can't have it minimized when I start if I want to do that. Okay. Let's try again.
Great. That's good.
Okay. So I'm going to just run quickly through clouds, actors, and how they fit in the IBB. I hope there'll be questions. I'm not going to explain everything in detail enough to do anything because we don't all be here next week. But first of all, I want to point out again that the meaning of cloud computing has changed. When I first saw the term cloud computing, it meant someone saying, we don't care where you put your server. It could be under your desk. It could be down the hall. It could be the data center. And that's all it meant, is that we're not going to say where it is. By the 2000s, it had pretty much had been rebranded as the big tech data centers, Amazon, Google, Azure, IBM. And people were often talking still about forklift migrations, by which I mean, just take this application that's under your desk, you find out something that doesn't work and you make it unchanged and not re-architected up in the cloud. By the 2010s, people were beginning to talk about the way coding the way Google did. Google was very famous then for having lots of the cheapest hardware you could find and switching quickly and adding a new computer for just a minute and then taking it down. And that was nice. And now it's moved on to cloud, meaning that wherever your cloud is hosted, whatever location, you write as if you're hosting on big tech, which is a different kind of writing and a different kind of architecture. But one, I think, that offers more benefits to the Internet of Things and smart buildings than to any other part of today's computing world. So Anto has touched on the cloud native computing. This is who's defining the standards for cloud native. It's a top level project of the Linux Foundation. And its goals that every program be written as if it's in the cloud. And every once in a while, something breaks into the news, or some hack breaks into the news, or some takedown of some system breaks into the news. And people talk about, oh yeah, well, we're interacting with this program over there, which is going with that program over there. And it seems complicated, but it's actually simpler once you wrap your mind around it. Cloud native computing has roots in the actor model, which has been there since the 70s. Intel kind of destroyed the actor model for a while because it allowed people to write monolithic programs as if they were on mainframes. And it sounds crazy, but when we got 640K on a PC way back when, I was working on mini computers where I had 28K computing. So 640 was huge, and you just made all your programs big and fat. You didn't have to have an architecture. You'd have this one big monolithic stack. The actor model instead treats the basic building block as an actor. It's an independent, autonomous unit, and you talk to it, and it replies back. But it's not doing what you say; it's doing what it says. So, I mean, there's a summary there right from the definition on Wikipedia. An actor, when it receives a message, can make a local decision, can create new actors, even can send more messages, and it determines. But it's all it's not all in one computer. It's all a bunch of things that are embedded in a message fabric. And if you want to influence, you influence the message fabric. You don't rewrite any of the actors. I know actors that have been in place for 25 years unchanged, but the systems there are not unchanged. Anyway, there's some stuff written down there, which is nice, but it actually might lead to what I would call decomposition of systems. So clearly we're talking about the IBB, the in-building box. We talk about many systems, but that they're interacting. Well, a system can interact as if an actor, or it might interact as if it were several actors. if you have a common messaging framework between them and standardize the message payloads, you can have different brands of smart building stuff interacting as if they're the same actor or the same type of actor. They send messages the same way, they receive messages the same way, but what they do with those messages is different. There's one, and I promise this is the last new Geek Speak I'm going to introduce in this. There's something called Open Telemetry, which came out as a nut project of the Cloud Native Computing Formation. Many of us have learned to go right to the system message log to see what's going on, the system event log. A lot of things in the smart building space have their own event logs and their own alarms. Open Telemetry is a standard where we can say, all these things, all these events, all these alarms are going to one space over there from multiple systems. Open Telemetry could maybe place that great system log in the sky or down low, or it's up to you. But so that's the last technology term I'm going to introduce, because Open Telemetry and actors means that you can have all the flexibility of actors and different systems interacting quickly and lightly and loosely and being reintegrated in different ways, while still having a common message log, a common forensics for the system, the common way to look at things. One thing I see is potential decomposition of systems. Once the big chiller in the basement is built as an integrated unit, we look at it often in the BAS system, for example, but maybe it should be its own actor. Maybe it should be responding at a higher level. It's a self-contained system. Nobody can see what the technology inside it's doing. There's nothing useful that the BAS says to the inside workings of the big chiller in the basement. So maybe these systems start decomposing into multi-actors, because cloud computing is based around multiple actors. But the last thing that I'm going to talk is that cybersecurity is known to do a lousy job with cyber physical systems. And the reason for that is 95% of all cybersecurity that you can see, and even the best organizations at some level, is defending a Novell network from 1987. It's making sure, guarding the modem. Well, now it's a router. It's seeing how bad traffic's going between the workstations. It's making sure nobody's deleting all the files on the file server. It's making sure people aren't inserting bad data in the database. And they've moved from very static systems to blacklists, to whitelists, to artificial intelligence, but they're still doing the same things. None of that tells you if someone is hacking the HVAC system. None of that tells you if someone is interfering with the access control system. None of that tells you if someone is hacking the foot traffic system in a retail store. Because the cybersecurity systems don't know what those things are. But what they can see, and what's very good and goes to their sweet spot, is noticing that the patterns of messages changing. So once you have actors that are all communicating as messages, you can have additional machine learning actors that are subscribed to the same messages. They may not even know what they mean. Maybe they're encrypted, it's not allowed to read them, but it notices the patterns change. And that becomes its own kind of cybersecurity, and one that deals with, well, stepping back a bit. If I want to hack your system, maybe the thing to do is to get my system to lie to it. How do I get it to lie to it? Well, maybe I interfere with a sensor, or I put gum on a sensor, or I hit the sensor with a hammer. There's all kinds of things I can do which make a downstream system be hacked. But if you can see how the message fabric is changing, you can determine these hacks and cyber physical attacks. I was describing that to my wife, who's very long suffering on long drives because she has to listen to me prattle on about this stuff. And she said right away, this is the Chatelaine model. She reads a lot of 19th century novels, and the Chatelaine was the mistress of a chateau or country estate, who may not have everybody work for her, but she has keys and she knows how to look at things, and she notices things going wrong. There's no buttermilk today. Why is that? No milk butter day. Why is that? Cow dry up? Butter churn broke? Did the milkmaid get married and go to another chateau? Can't be told, but you can just see that something is wrong in the effect and follow up and track models from that. And since I named the Chatelaine model, many people in surprising locations have said, oh, good, we needed a name for that. We've been doing that. So I'm proposing the Chatelaine model, which comes out of something to put in the IBB to watch not the individual systems, but how the systems interact with each other. in a way that can be learned, understood by machine learning, and then apply artificial intelligence to see how it goes forward. So that's a quick spin through cloud native computing and the actor model and how it changes things. It relies very heavily on standard messages between things. You don't want one of these messages that sometimes says 3 parameters and sometimes 42 that you get in coding sometimes. You want very standard messages that look standard ways. And then you can secure them, then you can share them, then you can reroute them, then you can forward them to external things and make the system of systems very flexible, very evolvable, while still secure. Anyway, I think that's a quick model. If you let me talk any longer, I'll plunge into all kinds of language no one wants me to say. And but I'm happy to answer any questions that there are.
So the core of it is this concept of being able to split apart the components of computing into actors, right? And because the cloud, and in our concept, we're talking about multi-cloud, which includes the building itself. So the building is not a foreign thing to the cloud. It is actually part of the whole multi-cloud. Then things, applications or logic or whatever it is, or storage can actually be wherever it needs to be, where they can best be located for whatever reason, latency.
Sure, absolutely. Since the messages are how the units talk rather than being part of one big program, any place the messages can flow, the different components can be. It may be this wants to be up in the Azure cloud or in the Amazon cloud for performance or for quick scalability or something. Or it may be that I have to have it on site because I just can't tolerate the security or privacy hit from shipping it off site. That doesn't matter. That's a deployment decision. It doesn't change the code at all. So that's part of the flexibility is you can relocate things as you want. Once you have a message fabric, well, any message channel could be a party line. So, and I know this crowd is old enough they remembers party lines, but you pick up the phone and you can still hear Mrs. Smith next house over talking. So you hang up and wait 5 minutes and then see lines free. But if there's a party line, then I can have the same message that comes from an actor and then have the message fabric send it to one other actor within the IBB and send the same message up to another actor that's in Google. And since I'm not waiting and I'm not deterministically doing, I'm just telling that other actor a message. I don't really wait for it to come back and verify that I'm sending it to 2 people or 10 people becomes irrelevant. So you can really get almost infinite reconfigurability of the systems and rescalability as you need it. Functions can be added, brought in without reintegrating or changing it. You just change the message fabric. So it takes you a while to wrap your head around it, but once you do, it's really hard to see doing it any other way.
I guess this, Toby, of course, assumes or needs all the actors speaking the same language, you know, because if you've got some talking Arabic, others talking Greek and whatever else, we got to at some stage get everybody at least on board with some sort of standards of how these sort of things should be interacting.
I think that's true, but it doesn't have to be universally true day one. If you don't have any ancient Greek actors in your building, then you don't have to worry about those messages yet.
No.
Or how to align with them. You want to have ways that you can formalize. And this is one of the things that's nice about connection profiles as they're defined. It imagines people defining common messages and being able to pick and publish those common interactions, common message patterns. And I can say, I think I want to use that one. Then you can put that interface on each system. Over time, someone will say, these are very useful messages. Let's standardize them. That'll come. But you can do a lot of good without getting to that point of standardization yet. As we move down and as we as an industry learn how to use this approach.
Toby, couple questions. This is Steve. One on your OpenTelemetry.io, is that sort of a cloud or modern version of SNMP?
Well, yes, but not entirely. So it's also a cloud version of the event log.
Okay.
So anything that you can query things and get an open telemetry response, but something that says, I want to write this down. And we all know systems that have been debug mode and filled up whole event logs again and again really quickly.
Sure.
And are dispersed. So, but it's this common thing that no matter where the message to the event came from, you can figure out, trace back where it came from, what the app was, what it thought it was, and then there's a part inside which is specific to the app, is not standard. But
Yeah, I guess
find out
where
the
I'm
details
going
of things.
is, you know, the IT industry standardized on SNMP as a means for all these different components.
I would say SNMP has its point, but only if it's the most barely integratable system. I still think the very best SNMP app ever was the very first one, which is so the grad student who invented SNMP could determine the temperature of the Coke can at the bottom of the stack, because he always wanted to make sure that he got that a cold Coke can rather than one that had just been put in the stack. And that was the original SNMP. It's great for saying, what's going on this one thing? There, it's back. This is different because every system that's going to the same open telemetry cloud can have its own logic, its own meaning, its own stuff. It's not going to standard MIBs like SNMP does. But you can have details and you can have additional details and follow it. So I think in a way it's a much more like, I was going to reach for a model, I'd look more like, say, the Windows event log or something like that.
But it does define it finds a methodology and a protocol as well, correct? And how to do it.
Yes, and it's open source.
Yep.
And the messages can be encrypted when they're in flight if you want.
Okay.
As a matter of fact, it's preferred they're encrypted. And
so, but the
what
point is
messaging am I
you're
using?
advocating that the IBB would adopt this open telemetry methodology as a key component of the architecture.
I think it's bound to sooner or later. I don't think I have to advocate it. I'm just naming it because I think eventually, once I have 7 different systems in my IBB, I'm going to want to start correlating between them.
Oh yeah,
How do I do
no, I
that?
agree. It solves a very, very common problem, is what I'm saying. And was open, I'm not familiar with it, but it was open telemetry developed as a solution for cloud deployments.
It was developed within the Cloud Native Computing Foundation.
Okay. That
For
answers
cloud
my question.
platforms.
Yeah.
And
that's great.
it was interesting. There was about 6 proposals for this that were floating around, and all of them had strong partisans, as you might expect.
Yeah.
And Open Telemetry came out with their first draft, and within 2 weeks, everybody said, no, use those guys' stuff.
Oh, wow.
It just
That's
wasn't.
great. That's great. All right. So then my second question had to do with connection profiles, because that addresses what Roger was talking about, this sort of common methodology where the different apps that are resident on the IBB can talk to one another in a prescribed fashion. So do you feel like that some version of connection profiles also needs to be part and parcel to this product?
I believe so. I believe so. If I imagine where connection profiles will go in the future, and I'm talking about as the standard that we hope we'll see at home in the ITF, but maybe someplace else, then I think we'll get to a point where I will be, as a Visual Studio programmer and an Eclipse programmer, I will go and read the big registry in the sky of connection profiles and say, I want to have one of those. It'll develop a stub for me in the code in the development environment I like, in the language I want. And then I'll connect that stub up to my code.
Yeah.
That's how I think it'll go. But we're not there today. I would pretend otherwise. But I think standardizing around something like connection profiles means we're going to standardize something around correct stub generation.
Mhm.
And connection profiles itself, the specification is moving to ever more specificity. There's some things that you have to be loose with because you're getting two systems that are not very specific.
Mhm.
But if you're really going to make cloud native computing style work, you want to validate the message as it arrives, before you've cranked up your code, before you've alerted the database, before you've tried to do something. It's got to be a valid message.
Yeah.
And a valid message might be not just an integer is here, but it's an integer between 7 and 13.
Yeah.
So it's actually valid messages that you can interoperate with. And that's coming to the that's what turns it into what cloud programmers would call interfaces, formal definitions with formal meanings. And that direction is underway in the
Yeah, I think
connection
that's,
style.
I think it's really critical for our industry because we're so context dependent. You know, it's, you can't just take something from an access control system and feed it into a building automation system without understanding the context of it.
Yeah. And I think the pattern of connection profiles, if connection profiles are the one, is there's going to be a huge explosion of them because everybody's going to do their own.
Yeah.
And then after a while, people are saying, hey, these ones are like each other, can't we consolidate it? And they will.
Yeah.
But until people start using them, it'd be foolish to try to consolidate.
One thing that's interesting about the cloud native thing that Toby's been presenting is that it's about the actors, and the actors are Yuval Lowy, the developer that Toby and I converse with quite often. He talks about the actors as being dumb, right? Because he wants the actors just to do what they're told. They don't need to think, right? If you give them an input, it does something and it spews out some output. That's all it needs to do. It's like an actor, like a real actor in a movie set. You just want them to read the lines. You don't want them to think, right? And the sort of the continuation of that is that if the actors are relatively dumb, then where is the smart? Where is the intelligence of the system that we're trying to accomplish something like controlling HVAC? And the answer of that is in how the actors talk with each other. The network is really where the intelligence and where the information is. And tying it back to connection profile we were talking about earlier, connection profile is exactly that. It models the relationship between specific actors. So that's how I just wanted to bring it all back.
I think that's almost right. And I say this on the basis of what I've been thinking about for transactive energy for a decade and a half now. It isn't that the actors need to be actually stupid. It's that their intelligence is not part of the interaction.
Yep.
It's a fundamental difference. And if you go to an economic world and you go to the farmer's market and you buy something, it's a dumb interaction. I like that eggplant. It's nice and purple. Give it to me. But what are you going to do with it? Are you doing some sort of French country cooking? Are you doing Middle Eastern cooking? Are you got fine that you're doing Chinese cooking, all of which use eggplants? All of them use it quite differently. What the intelligence of which what that is, and whether you're a good or a bad cook, is entirely outside of that interaction of give me an eggplant and I'll hand you cash. So that's a dumb interaction. It doesn't say that there's nothing smart inside on either side of that. Farmers may be a good farmer or a bad farmer, may do stupendously smart stuff, but it's not part of the interaction. So that's the one difference is we want to keep the. Does that make sense?
Yeah, yes, it does. I was exaggerating a little bit as I haven't.
I thought yours was fine. I just wanted to make sure that people got that, and you were thinking, but I made a smart building thing that's so smart and it does something. That's wonderful. But the integration with it should be simple and easy.
So I'm going to bring in Al Putnam because he's part of the IBB project. And I kind of wanted to shift the conversation about what does this mean for building automation? I mean, there's a lot of controllers, there's a lot of computation that's already happening. what does it mean in terms of people thinking about the cloud native? And maybe somebody can speak to that while I bring Al in. Is this a re-architecting of everything, or is it? How do we start to think about implementing cloud native?
I'll jump in because I'm going to have to jump off the call here shortly. But from my point of view, this feels and smells a whole lot like just best practices and distributed controls, right? So I've been involved mostly with networking and distributed controls where, you know, the intelligence is mobile and can be moved around in different places, and there's no single point of failure, and messages get repeated, you know, down the path or up the vertical pipe as it will be. So from a best practices standpoint, a lot of what is being talked about, I think, is just good architecture in general, right? And the cloud is uniquely built to be able to provide a lot of those benefits. So I don't know that it's a re-architecture of a whole lot of stuff necessarily. It depends on where you're starting from. But
yeah, I just make one comment on that, and I'll ask Al to respond. But if you recall, on the first week of this month, I was just showing the sort of a typical control hierarchy, which is a distributed computing. I think the difference, the reason I wanted to show that and contrast it to cloud native or sort of multi-cloud is that in the control system, there is always a hierarchy, right? There is always a hierarchy that starts typically with a supervisory PC. These days is on the internet sometimes, and there's some kind of controller or some other kind of controller, and maybe a sort of zone controller, and then some devices, and then IO at the bottom, right? So you can't just move things around in that architecture. You can move things around within the hierarchy where it allows, but the hierarchy is actually defining a structure of where devices can go. Whereas in cloud native, you don't have that limitation. You can literally put a processing unit in the IBB or in the cloud, and it really doesn't matter as long as you have the messaging mechanisms.
But I guess, Anto, that depends on how far, as you start looking at edge type controllers and computing, then you get the flatter architecture, which would allow the change for that to happen in a building,
right,
to be just part of this whole, flat architecture. It doesn't matter where it is in the cloud, on prem or nothing, doesn't make any difference. So it's a matter of our industry now moving that intelligence down to do what Tracy was talking about, having distributed intelligence, but just moving it down now, so it's doesn't matter where it's at. It's just on the same platform, same network.
You might get some big applications that need to interact with a lot of other actors, and using the connection approach, you may say, oh, this one will pretend it's this kind of actor when talking with that guy, and this kind of actor talking to that guy. So that would be one big system, have multiple actors, multiple interfaces on it that are part of different message fabrics. I think over time it does re-architect, but it certainly isn't so now we rip out everything because nothing will work until everything has been rebuilt tomorrow. No, we just give it 9 different kinds of connections tomorrow. And then over time, the re-architect, as Tracy says, just becomes, you just start more closely following best practices. Over.
Al, do you want to chime in on this?
Well, I've been following along with the IB. Oh, first, I'm Al Putnam. I'm with Symmetrics. I'm along with Jim Lee, and have been. I should start it like an AA meeting. Hi, I'm Al. I've been in HVAC for about 20 years. Anyway, the IBB in relation to cloud native, I'm sort of along for the ride to listen in and find out how it applies to what we're doing, what all of us are doing, and whether the time is right for such stuff. And cloud computing, the times now, and the things for the IBB, the way that it can use cloud computing and use the models of cloud computing and do things kind of the way it did it before, but morphed into a cloud computing model, are the things that are kind of really exciting about it. I considered this as like a question and answer period with Anto. If Anto wanted to ask like questions, we've been doing a lot in the IBB about, what would the questions be that people who are coming into seeing cloud computing or seeing these new ideas of virtualization or seeing new ideas of how systems connect together, what would be their worries? What would be their pushback? What would be the things that would be a barrier above and beyond their worries to adoption of something like cloud native or the IBB? There's been a lot of discussion in the meetings about what were the barriers, and some of the barriers have come and gone. Are there network connectivity issues? No, cloud computing is all about networks. Are there IO connectivity issues? Some people are very concerned about how you get out to sensors and how you get out to monitor things that are out there in the real world. Most people have handled, or the community in cloud native computing and the community in virtual machines have largely seen that you do need to get out to some real stuff, and you can handle that over the network. You can handle that real stuff over the network. You can go over the network and get to those real things. So that's not really a barrier. There's business opportunity barriers, or people that, this impacts their business model. I've done a lot of boxes. I've built a lot of boxes. A generic box may or may not be good for me. I'll leave that aside for you to kind of consider, and other people to consider, because I'm mostly on the technical side, although it's interesting to think about what kind of business impact there is for the new ways of thinking about cloud computing, the new ways of thinking about virtualization, and your machines not being real machines, but being a collection of processes or a collection of actors and actions that those actors do with each other. Go ahead, Beth.
I was just going to say, we are planning to cover the business side of cloud and IBB next week, right? So we want to dedicate the whole conversation, because you're right, it is actually a barrier to understanding how this can roll out and what it does to the industry. So we'll have that discussion next week. But I'm not the only one that have questions, so open it up to the group. Any other thoughts?
I would, just because sometimes things go by in the chat without being caught, I highly recommend Gregory Kumar. I'm not sure how. Sorry if I made that. He cites the rules of Admiral Hyman Rickover, which actually he's the third person who has cited that since I started talking about the Chatelaine model a few weeks ago. And it's about as far away as you could get from one direction to the other level. It's a very good discussion of why actors work in things. So it's a PDF. Click on it in a side link, read it later. It's a good philosophical approach to cloud native computing and to Chatelaine security and to similar models. Over.
But I guess the Chatelaine thing, Toby, is quite an interesting thing, because I mean, a group of actors is no different to an automation system. When it first starts up, you need a director to actually put it all in place. Then they can interact and they go on and do as many shows as they like, but it's repetitive. And it's the same as a building automation system. At some stage, you've got to get that information to some people that can make it, change it, update it, and do it so on. And what this infrastructure does, I guess, is allow other players to come in and modify, what could become stale because it's just mechanical. Building automation systems, once you've actually been designed and put in, runs exactly the same. It's not making any intelligent decisions at this stage. It will go on to do that as we evolve. But I guess what this is doing is allowing other directors or conductors, if it was an orchestra, to come in and actually start making the changes, who have got more intelligence to add to it, because that's their skill set. Is that fair?
I think it is. And part of the notion is that these two things have never interacted before or been seen to interact with each other before. So how do we know if they're interacting normally? So an ML machine learning actor that's watching them figures out what's going on. This actor always demands that he get a soft-boiled egg exactly an hour and a half before performance. If he doesn't, something's going on wrong. It's doesn't require a theory. It's just observation and understanding what is and being able to automate the observations of when something is going wonky in some way.
Roger, you weren't on last week's call, right?
No, I wasn't able to.
Yeah. So just to remind, just bring up the point of what what we're trying to do with IBB is write a specification and bring it to potential manufacturers to build a product that does this.
Yeah.
So it's really about what does the product have to contain? What feature set does it have to comply with to fulfill the purpose of the IBB?
Okay.
And think of the IBB as a sort of a micro data center that's on-prem.
Yeah.
Yeah.
Right, with containerization and everything else. So
Sure.
it's just like a big data center, except that it's small and it's on-prem.
Yeah. Okay.
And this sort of, to me, one of the interesting things about IBB and cloud native is that we've heard forever, it seems, the debate about whether something should be in the cloud or on-prem or local on the edge. That's always been a sort of a debate in the industry. I've been on panels. I think I was on a panel with you, Mark, talking about that some time ago. And to me, what the IBB and sort of thinking about it in cloud native kind of solves that problem, because
Yeah.
it's
Makes
IBB
makes it unimportant. It's like,
right. It could be both.
yeah, it can be
So
both.
an application can actually be on the IBB, behaving like a cloud, but it's actually on-prem. And if you want
Right.
it to be in the cloud, it can be in the cloud. So it kind of makes
It
Makes it
takes
irrelevant.
it takes the common components and you decide where you're going to put it based on performance, economics, security, privacy, resilience. But those are all facts of the exact decisions you made, but don't change any of the code.
Right.
Don't change any of the components.
No, I really like it. I love it. The concept. I mean, this is frankly a pretty dry conversation to have on Monday Live, but it's nonetheless, I think doing this is not just a valuable exercise, but a really way to solve a number of problems and get the industry moving forward in an area that's critical.
So Jim, do you want to chime in?
Decomposing is not important or interesting. Hey, Toby, the concept of decomposing, of course, means you break something apart that was put together for a certain reason, but you can now break it apart and recompose it into for even greater benefit, right? That's your point about decomposing.
Yeah. So something. One of my horses that I get on and ride all the time is smart energy. People who know that know about it. And one of the problems we have is that when things are integrated in the field, they don't have meters in the right place. Lots of these components should have sub-meters built into them, but they don't, because they don't matter to today's systems. But if they came as independent actors with independent systems, they'd have better meters installed in the factory that they just arrived with, and anybody who wanted to read it could read it. And that before you only got the facts that the system was integrated with, cared about. And that system may have other facts that are useful for other people to share, but it's got no way to talk to them in today's integration model with one big unified stack. Once it's different actors, then anything that they can share with others, and the adaptive reuse of that information is, I think, where the smarts come from.
Jim, I was going to ask you your sort of thoughts on this from a vendor, from a manufacturer of both boxes and software and infrastructure.
Well, I'm trying to figure out who's responsible for this damn thing. I mean, I think that's a really interesting question. It might touch too much on the business side that we can hold. But you're, is this a MSI thing? Is this your IT integrator? Who owns it? What is it? What class, what flavor is it really?
For this at the start, there's enough owners that are willing to take ownership of it because they're frustrated with not being able to get it from off the shelf yet. It's the same thing as happened in the IT world. When there was evolution of technology, there weren't necessarily all the pieces that you could just go buy off the shelf. And owners would step in and say, you know what, I'm just going to have to figure out how to use the skill of my MSI, use the skill of my vendor. I'm going to have to take some responsibility on my own. And there's enough of those that that will do that we're all going to have more work than we can imagine.
Interesting. Well, the other question is skill sets. Where do the skill sets reside in the channel, and how can I put one of these things together and field it? So the way I look at it, it's an integration that's going on in a third-party open specification. It's an integration not of data, which we have things like BACnet and other things to do, but it's an integration of actors and applications, which we don't really have a lot of experience doing right now. So who does that?
I think that's a wonderful question for us to continue next week, because it's a, I can't help thinking that we all are sort of doing that on our phones for our personal lives. We're actually integrating stuff. So part of me wants to say somebody that's very close to the end use of the system.
Mm-hmm.
Obviously, it's very different to smartphones, but when you install Mint Mobile, or it's not Mint, but some financial system on your phone, and it connects to your bank and all that kind of stuff, that's basically what you're talking about, how you connect these pieces. And so it is a different paradigm, because you're no longer sort of integrating using APIs and code.
Right.
Yeah.
So lots of things to figure out. But the basic idea seems pretty sound and much more straightforward with today's technology. So I'm excited about it.
Mm-hmm. Hey, Mark, do you want to chime in as a last word on all of this? You've been very quiet. You've been observing and taking it in. You're muted.
No comment.
Okay. Then that's great. Look forward to next week's conversation. Thank you, Toby, for making it all clear to us, and thanks, Al, for another perspective. I think this is an interesting subject, and we'll figure out the business side next week, and we'll get video of this tomorrow or the day after, and wishing you all a great week. So,
Okay, very good.
bye-bye.
Thanks, everybody.
Bye.
Bye.